Good morning, Kanishka, Divya, Shrutika, Sharmila. Good morning, everyone. So last class we started. Last class we were discussing about structure of atom. In that we were discussing that how proton was exactly discovered. Just start typing and telling me the answers. Who discovered proton? Name. Who discovered proton? Come on, quickly. Chalo, let's have a rapid fire. Who discovered proton? Who discovered proton? Quickly tell the answer. Who discovered proton? Good morning, everyone. Who discovered proton? Very good. Goldstein. Actually, the proton rays were coming from anode, or proton rays were coming from, anode rays were coming from anode rays were coming from anode. Am I true or false? Anode rays were coming from anode. Am I true or false? Very good, Sharmila, Shrutika, Vishal. Anode rays were coming from anode. Am I true or false? Absolutely correct. It's exactly false. It was not coming from anode. Anode rays were not coming from anode. That statement is absolutely false. Next question. The anode rays were anions. The anode rays were anions. Means gaseous atoms, when from their electrons were knocked out, they formed anions. So gases were, anode rays were anions. Quickly tell me, the answer is correct or wrong? Anode rays were anions. The statement is correct or wrong? Anode rays were the anions. Krisha, good morning, beta. False. How it is false, beta? Yesterday itself we have discussed about it. Yesterday when we were discussing about it, I discussed one very important point, that between cation and anion, the gaseous molecules were there, and these gaseous molecules, first due to the presence of current, high amount of current, these gaseous molecules got broken into gaseous atoms, and from these atoms the electron from the outermost orbit got knocked out. So electrons from outermost orbit got knocked out. Because of knocking out of that electrons, the atom got converted into ions. And beta, these ions were started traveling from anode towards cathode. These ions which were positively charged that only started traveling from anode to cation. So how this statement is false? Come on, quickly tell me how this statement is false. Yesterday itself we have discussed about it. Very good. So they are exactly positively charged ions. Correct only. Super, Shrutika. So they are positively charged ions. So these gases were positively charged ions. So positively charged ions are called as cations or anions. Good morning, Jiva. So they were what, beta? They were positively charged ions. So that is the shifting of ions. It's not anions, they were exactly ions. Super. So now we are going to go towards proton. We have discussed and we understood that golden experiment was totally replica for J.J. Thomson. Whatever J.J. Thomson has done, Goldstein has also done, and in all that experiment he came to come out with certain values of proton. And what are the values of proton? Let's see the values of proton. What we have encountered, we saw that the charge of proton is just similar to that of electron. Though electron is negatively charged, proton is positively charged, but proton value, the value is exactly 1 unit positive charge. 1 unit positive charge or 1 unit charge of proton was 1.6 into 10 to the power minus 19 coulomb. 1.6 into 10 to the power how much? 1.6 into 10 to the power 19 minus 19 coulomb. It was exactly 1.6 into 10 to the power 1.6 into 10 to the power minus 19 coulomb. That was the charge of proton, same as 1 unit charge of electron. Electron is negatively charged, proton is positively charged. This we have seen, but charge by mass ratio of proton is 1.67 into 10 to the power minus 27. But it is exactly more than electron. If we are going to compare now, then we are going to see that electron mass was, what was the mass of electron? 9.1 into 10 to the power minus 31 kg. Okay, I just said that mass, charge by mass is exactly this much. That is 9.58 by into 10 to the power 8. That is exactly 1.76 into 10 to the power 11 was there, and here 9.58 into 10 to the power 8. But here mass of proton is more than that of electron. How I came to know that mass of proton is more than that of electron? Okay, is more than that of electron. Check this one out. Electron mass is 9.1 into 10 to the power minus 31. 9.1 into 10 to the power minus 31. But here beta, you see mass of proton is 1.67 into 10 to the power minus 27. Beta, in negative, whichever is exactly bigger is actually smaller. Okay, so here mass, in mass you see in electron it is 10 to the power minus 31, and proton it is 10 to the power minus 27. So since this one is bigger than this one, so mass of proton is more than that of electron. Mass of proton is more than that of electron. I hope you might have understood this point. Come on, quickly tell me. Mass of proton is more than that of electron. Mass of proton is more than that of electron. So I told my point, mass of proton is more than that of electron, is more than that of electron. Sharmila understood? Mass of proton is more than that of electron. Lokesh, Shiva Naresh, Rahul, Ashwin, Avinash, Darshini, Divyashri, Ashwarya, Shrutika, Satyashri, where are they? Morning class is going on, where are they? Where are they? Good morning, Avinash. You got saved yourself. So we understood that protons are positively charged. So how to define proton? How to define proton? A proton is defined as that subatomic or fundamental particle. See beta, the subatomic particle are also called as fundamental particle. So proton are defined as the subatomic particle or fundamental particle which carries 1 unit positive charge. Which is carrying how much? 1 unit positive charge and has mass nearly equal to that of hydrogen atom. Think, mass of electron is 1 by 1840 times of mass of one atom of hydrogen. That is exactly very, very less. But when we talk about mass of proton, we are exactly coming to know that mass of proton is exactly equal to that of hydrogen atom. Mass of proton is equal to that of hydrogen atom. So this is exactly a unique thing we have understood. Yes or no? Tell me quickly. Isn't it very amazing that we understood this point? It is exactly different. See, I say one thing very important today. See, some children are there among you. when like Kanishka is there, you all are Ekta, Kanishka, Shrutika, means those who are present right now. Why I'm saying that, why I'm talking all your name, that you are so attentive. Like if late also is coming, means you are coming in the class and you are saying auntie, sorry, I came late. And Kanishka, she is exactly telling, auntie, this is the time. Whatever mistakes are there, she'll also tell that, auntie, this time I can be able to join. So I'm really respecting you all children, that you are so much into your work. And some children, you see, it's the time and they are still sleeping. This is really very bad. Very, very bad, because you should give importance to your duty first, and your duty is to first learn. Okay, so this is really bad. Really bad means you should be present in class in morning because whatever doubt will be there, you can ask that time. It's not good. So I'm also watching in future with whom I have to stay and with whom I have to leave. So it is also one of situation for me to check. So now look here, charge of proton. Charge with proton means 1 unit charge. Keshav, what is the difference between mass of electron and mass of proton? Okay, what is the difference between mass of electron and mass of proton? Difference between mass of electron and mass of proton. Mass of electron and mass of proton. Difference between mass of electron and mass of proton. Come on, let's see who can answer. What is the difference between mass of electron and mass of proton? I am not asking in values, but I just want a comparison. I just want a comparison that, okay, if I am saying that mass of proton is this and mass of electron, then I should have a concrete point of saying that. I should have a concrete point of saying that. Ma'am, proton has more mass. Absolutely correct, Keshav. So when somebody will compare, then you will say that, auntie, proton is having more mass. Exactly, the mass of proton is equal to mass of hydrogen atom. 1 unit hydrogen atom is 1 hydrogen atom mass. It is exactly going to make it equal. But problem with electron is mass of electron is 1 by 184 times, 1 by 1840 times exactly to that of mass of hydrogen. That means electron is exactly very, very less mass. The mass of electron is very, very less. So by understanding this point, if somebody will say that the entire mass of the atom is exactly concentrated in the nucleus or concentrated in the orbits in which electron is revolving, then which statement is exactly going to be the correct one? Which statement is exactly going to be the correct one? The mass of atom is due to mass of nucleus or mass of electrons present on the extranuclear part, or mass of electron present in the extranuclear part. Come on, Vishal is telling the first one is the correct one. So first one, what was the first one? I said first one means nucleus. Now let's check this one out. Let's check this one out. Tell me quickly what this answer is, because after this we have to start cations. Cations I'm saying. After this we have to start about neutrons. Very good. So exactly mass of is due to nucleus. That is what the beginning part of the class I discussed. The mass of the atom is due to the mass of the nucleus alone. Okay, and in nucleus what is present? Proton is present, and mass of proton is much higher than that of electron. So I think the picture is very clear to you. The picture is very clear to you now. Yes, absolutely correct, Sharmila, Vishal. So exactly now the picture is somewhat clear to you. Now you can be able to differentiate the contents and things. I hope you might have understood this point. So now we are going to go towards the next point. So proton part we have understood. The content related to proton we have understood. Mass, charge by mass of proton we have seen. We discussed the point also. Now it's time to talk about neutron. Okay. Now according to the discovery, you can see that the discovery of neutron was very late done, where electron and proton was done in 80s, exactly 80s means 1800 century. But here you are seeing that cathode was, Chadwick, James Chadwick has exactly proposed a point where he said that in the nucleus it is not only proton, but with proton something else is present, and that else is contributing in the mass. Because if I am checking the mass of proton, then mass of proton alone cannot make the mass of the nucleus. That means something else is there. So if I am telling, just understand one thing, I am standing somewhere and my mass they are telling that, my mass they are telling that I am exactly 60 kg. But the place where I am standing, the mass is, the overall mass is coming as 100 kg. So tell me how much mass is missing? How much mass is missing? So exactly what happened, I am repeating, because they thought that since neutrality is maintained, so there is only two things. Absolutely correct, Keshav. Because they told that positive charge in all the atoms are electrically neutral. So how much positive will be there? That much negative will be there. So positive, negative counterbalancing each other. So story over. Very good. But very absolutely correct, Vishal. So 1932 means, Avinash, it is very, very late, beta. It is very, very late. Rahul always used to come perfect time, but today what happened to him, I don't know. Yes, 40 mass is missing. So exactly my mass is 60 kg. And when you measured the mass of the place where I am standing, that means that mass is 100 kg. So we came to know that out of weight is exactly, mass is coming as 100 kg and Khushbu auntie's mass is only 60 kg. So that means something is missing, and that something is 40 kg. So same thing happened with the nucleus. When they checked the mass of proton alone, so they are finding certain other mass. And when they are checking the mass of nucleus, the mass of nucleus is something else. So that means what? We understood that some mass is missing. So where is the mass going? How it is coming? What is that which is present in the nucleus? What is that? Kanishka, just understand, you and me, we both are standing in place. Now my mass is coming as, so that place where I am standing with you, total mass of that place is 100 kg. Okay. Now people know my mass. They know that I am 60 kg. And people are only thinking I am only present. Kanishka is not there. So everyone is thinking only Khushbu auntie is present there, and the total mass of that place is 100 kg. And my mass is 60 kg. So everyone is thinking that because of Khushbu auntie's presence only, mass is coming 100 kg. But when they calculated my mass, they found that my mass is only 60 kg. That means how much it is missing? And who is having that remaining mass? Tell me. How much it is missing and who is having that remaining mass? How much it is missing and who is having that remaining mass? Come on, come on. How much it is missing? Okay, I forgot to take the name of Yogita. She is also missing. How much mass is missing, Kanishka? Very good. How much mass is missing? 40 kg is missing. And who is having that mass? Who is having that mass? Kanishka is having that mass. So that means we discovered that Kanishka is also present with Khushbu auntie. So only the mass of that place is 100. Same thing happened with nucleus. So when they started measuring, so they were always finding that there is a relative difference. There is a difference. So mass of nucleus, total mass of nucleus is exactly, take total mass of nucleus is 5 and mass of proton is only coming as 3. That means something else is present inside whose mass is exactly there, but we are not knowing what is present inside. But we are not knowing what is present inside. That is the exactly important concept you have to understand. Come on, quickly tell me, you understood this point? You understood this point or not, beta? Something else was there, Kanishka, something else was there, and that mass was missing. And so only that exactly gave the idea for the scientists to exactly come to know that what is present inside. And one important concept is positive number and negative number are counterbalancing each other and killing each other. Means they are making the atom electrically neutral. Then what else can be in the nucleus? Then something can be in the nucleus which do not have any charge but have mass. Something else will be there in the nucleus which do not have any charge, like positive charge or negative charge, but they are contributing in the mass of the nucleus. They are present in the nucleus, they are contributing in the mass of the nucleus. Come on, everyone understand? Absolutely correct, Avinash. So everyone understood this point. So they are contributing in the mass of what? They are contributing in the mass of atom, but they are not having any charge. They are not having any charge. I hope you might have understood this point. I hope you might have understood this point. Come on, quickly tell me, you understood this point? Yes or no? You understood this point? So only we came to know that neutron is neutral. So we came to know, understood na Sharmila? So only we came to know that neutron is neutral. So what I am telling you, I am just drawing and explaining. Just understand that the number of positive, the number of proton inside the nucleus is 5. That is 5 positive charge. The number of electron outside the nucleus is 5. So that means positive and negative charge is equal in number. Positive charge is 5 inside the nucleus, negative charge is 5 outside the nucleus. So these two are counterbalancing and making the atom electrically neutral. But our problem still remains the same. The mass of the nucleus was 100, okay, but proton mass was only coming as 60. So that means still 40 is missing. Still 40 is missing. Means something is present inside the nucleus which do not have any charge, but have mass. Which do not have any charge, but what they are having? They have mass. I hope you might have understood. Jiva understood. So exactly, I hope you might have understood the condition here. Understood the condition or not? Come on, quickly tell me. Did you understood the condition that something is present inside the nucleus which do not have any charge, no positive charge, which no negative charge, but that something which is present inside have mass, and it is contributing in mass of the nucleus. And it is contributing in what for the nucleus? It is contributing for mass of the nucleus. Contributing for what? Contributing for mass of the nucleus. I hope you might have understood this point. Yes, Sharmila, no charge but mass. So that means we came to know that neutron do not have charge but have mass. So now we are going to understand discovery of neutron. So in that what happened actually? So if there were only electron and proton in the atom, then the total mass of an atom must have been mass of proton. See, they are saying the same thing. The total mass of nucleus will be mass of proton. But as the mass of electron is negligible, but then it was noticed that mass of an atom was much more than that of only mass of proton. That means something else is present, and I am just making the entire story based on this only. So for example, nitrogen has 7 proton, okay, but the mass of nitrogen came as 14. Yes or no? So nitrogen is having 7 proton, but mass of nitrogen is 14. So electron cannot contribute in mass. Electron cannot contribute in mass, that means something else will be present there. So what that something else is present there, it will not be present in the extranuclear part, it is present inside the nucleus only. It is present inside where? It is present inside the nucleus only. So we came to know that whatever is present, it is exactly present inside the nucleus. So this problem was solved by James Chadwick. So discovery of electron, Thomson. Discovery of proton, Goldstein. Discovery of neutron, James Chadwick. Discovery of neutron, James Chadwick. I repeat, discovery of neutron, James Chadwick in the year 1932. He told that another kind of particle was present in atom, and this particle was named as neutron. Means something else is present in nucleus, and that name he has proposed is neutron. What name he has proposed? He proposed a name called as neutron. Okay, so neutron is particle with no charge and mass equal to that of proton. So now we came to know that okay, the mass of proton and mass of neutron is same. The mass of proton and mass of neutron is not different. James Chadwick, absolutely correct, Krisha, Sharmila. So the mass of proton is equal to mass of neutron. So we came to know that how much is the mass. So 1.6 into 10 to the power minus 27 kg is the mass of proton. So 1.6 into 10 to the power minus 27 kg is the mass of neutron also. So neutron and proton mass is same. Neutron and proton mass is same. So it is present inside the nucleus and their mass is same. So neutron provide the atom with mass. So that means neutron has no charge. It is electrically neutral. Mass of neutron is same as that of given. It is in gram given. Okay, it is in gram given. In kg it will be same. Okay, in kg it will be same, that is 1.6 into 10 to the power minus 27 kg. Okay, so same as that of proton. So the relative mass of neutron is also 1 u is exactly same as that of proton, same as that of proton. So that means now we have understood that mass of 7 proton and mass of 7 neutron. So relative mass when we are talking, then 1 unit mass of proton equal to 1 unit mass of neutron. So that means if mass of proton and mass of neutron is same and it has been taken as 1 unit, that means how much neutron mass is there, that much proton mass is there. So if we will take the mass of proton as 1 unit, then mass of neutron will also become 1 unit, and then together they will make 2 units. Together they will make 2 units. Are you understanding? So how much is the mass? I am repeating, how much is the mass of proton is there? We are writing the mass of proton as 1 unit. So if mass of proton is 1 unit and it is exactly equal to neutron, that means mass of neutron is also 1 unit. Mass of neutron is also 1 unit. Just understand this point very nicely. So we are converting the mass as unit. So proton mass is 1.6 into 10 to the power minus 27 kg, and this mass we are taking it as 1 unit. So neutron mass is 1.6 into 10 to the power minus 27 kg. So it will be taken as how much unit? It will be taken as how much unit? Come on, tell me. It will be taken as how much unit, beta? It will be taken as how much unit? How much unit neutron mass will become? Let's see who will type first and send. How much unit mass neutron will become? How much unit mass neutron will become? Very good. same as that of 1 unit. Clear concept, super Vishal. So here this much is taken as 1 unit. So since these both are same, so neutron mass will also become 1 unit. Correct Kanishka, neutron mass is also becoming 1 unit. So 1 unit neutron mass also we can take. 1 unit neutron mass also we are going to take. I hope my bacha party understood this point or not. Understood this point or not beta? Their mass is exactly coming as same. So in unit wise, correct Trisha, in unit wise we have taken that same. In unit wise we have taken that same. So I hope we have understood this point. We are going to see here, but electron mass is very less. It is exactly comparatively 1 by 1840 times the mass of one atom of hydrogen, and here the mass of proton is equal to mass of one hydrogen atom, the mass of neutron, since proton mass is equal to neutron mass, and they are saying that the mass of proton is equal to mass of one atom of hydrogen, then what will be the comparison between neutron and hydrogen? What will be the comparison between neutron and hydrogen? Come on, quickly tell the answer. What will be the comparison between neutron and hydrogen? What will be the comparison between neutron and hydrogen? Between neutron and hydrogen, what will be the comparison? Then you will say that, auntie, it is simple, auntie, it is not a rocket science, it is simple concept, auntie, that mass of hydrogen is equal to mass of neutron also, because mass of proton is equal to mass of one atom of hydrogen and mass of proton equal to mass of neutron. So here this will be, its mass will be equal to one hydrogen atom. So since proton mass is equal to one hydrogen atom mass, so definitely neutron mass will also be equal to one hydrogen atom mass, is equal to one hydrogen atom mass. So masses were same. So here also, that's why they have written 1 unit, but comparing to this, electron is coming as 1 by 1840. Charge is negative, charge is positive, it is neutral and revolves around the nucleus. Electrons are revolving around the nucleus, but proton and neutron is present inside the nucleus. Where is proton and neutron present? Proton and neutron is present inside the nucleus. I repeat, proton and neutron is exactly present inside the nucleus. Proton and neutron is present where beta? Proton and neutron is present inside the nucleus. So this was the concept we have tried to understand. Now they are asking this question, what are canal rays? Now can you answer the question? They are asking what are canal rays? Do you know what are canal rays? I think my children will be exactly able to answer now. What are canal rays? So if somebody will be asking you what are canal rays, will you be able to answer? No answer. What are canal rays? Yesterday itself we have discussed. What are canal rays? Yesterday itself we have discussed about canal rays. What are canal rays? No answer. Everyone is sleeping. Come on. Good morning, everyone. Canal rays. What are canal rays? That's it. Correct, Shruti. This much time taken, Shruti. I thought you are going to jump and type. Auntie, canal rays are anode rays. That's it. They are positive rays. These rays are anode rays. The canal rays are positively charged radiations and they are exactly anode rays. Who has discovered that? Kanishka, absolutely. So these rays are positively charged radiations. They are exactly positive charged radiations and they are also called as anode rays. So what are they? Consist of positively charged particles known as proton. So what exactly canal rays are containing? Canal rays are having proton. What canal rays are having? Canal rays are having proton. It was discovered by Goldstein. Canal rays are having proton. It was discovered by Goldstein and it is positively charged. And it is exactly positively charged rays. They are what? They are positively charged rays. They are what? They are positively charged rays. They are what? I repeat, they are exactly positively charged rays. So now we have understood about this. Now electron, proton and neutron. This is a super important question for your coming examination. If you think you can answer this question, means 100% you will be going to get marks. So I am just telling one very important question for you for your coming final examination is differentiate between electron, proton and neutron. So in your question paper, question related to electron, proton and neutron will 100% be there. So what answer you are going to say? Electrons are negatively charged, protons are positively charged, neutron is neutral. So electron is present outside the nucleus in orbits. Proton is present inside the nucleus. Neutron is present inside the nucleus. Mass of electron is very less. So mass of electron is negligible. Mass of proton is more than mass of electron. It is approximately 2000 times more than, more than mass of electron. Then we will say about neutron, the mass of neutron is nearly equal to mass of proton. The mass of neutron is nearly equal to mass of proton. That's it. 3 difference, 3 marks in your hand. So easy question and you can be able to get score in this question very easily. So now we are going to talk about Thomson's atomic model. So Thomson's atomic model, because now we have to understand that everything is going on, discovery of mass, charge, everything we are talking about, electron, proton, neutron was talking about. In between, J.J. Thomson has proposed another point. Kyunki positive charge is present, negative charge is present. An atom is electrically neutral. Atom is what? Atom is electrically neutral. Then where is the case of fight? Where is the case of fight where we are exactly going to understand the structure of atom? The case of fight is structure of atom. The case of fight is structure of atom. What could be the atomic structure? Number of electron is good. It is exactly equal to number of proton. But that time we were not knowing that there is a word called nucleus is existing. So when J.J. Thomson has proposed his point, he didn't propose the structure of atom. The structure of atom was proposed much later. So here you see that when he has exactly proposed the structure of atom, then he has exactly made a blunder mistake. He compared morning itself, so nice things, chocolate drawing, ice cream drawing, watermelon, cake, and this is dairy milk shots, small. So morning itself eating items they are showing, and they are showing that these eating items are like atoms. These eating items are like atoms. So are you going to trust that? These eating items are nothing but atoms. Why these eating items are exactly compared as atoms? Okay, then he proposed one very important thing, that he believed that number of positive charge equal to number of negative charge, and atoms are electrically neutral. Atoms are what? Atoms are electrically neutral. Number of positive charge equal to number of negative charge. So that means like cake na, like in cake, Christmas cake or like in watermelon, one part is positive, one part is negative. So he believed that atom is made up of positively charged substances in the form of sphere. Okay, into this sphere embedded electrons and equal amount of proton. So like you can see that pieces of apples are embedded in apple pie. Means in apple pie, how many pieces of apples are there? That pieces of apple you take it as positive charge, and the remaining region you take it as negative charge. So that means positive charge and negative charge are equal. Positive charge and negative charge are equal. Further, the total positive charge of sphere is equal to negative charge of electron, and hence atom remains electrically neutral. So I'm just laughing because his concept was exactly correct only, but it was not well presented. Concept correct means I'm not telling that this is the structure of atom. He understood about electrical neutrality. He understood the concept of electrical neutrality, means number of positive charge equal to number of negative charge, but he failed to present it properly. Okay, he failed to present it properly. Yes, super comparison. That is what the comparison was, absolutely super. So here we are seeing that he are telling that Christmas, that apple pie is there, in that apple pieces na take it as negative charge, and the remaining one will take it as positive region. Here also in Christmas pudding, Christmas cake also you take the cashews as negative charge, and the remaining one will become positive charge. In watermelon also you take the seeds as negative charge, and the remaining one will become positive. The remaining region will become positive charge. So number of positive equal to number of negative. So atoms are electrically neutral. Atoms are what? Electrically neutral. So Thomson model successfully explained electrical neutrality, but atomic model was unable to explain anything. So atomic model was exactly not the correct idea for all the physicists. Exactly, the concept was correct, but structure was wrong. Concept was correct, structure was wrong. So I am going to keep it till here. I am having class with class 10th. Evening we are going to talk about the most awaited experiment, and that is for Rutherford model of atom. It is the most important one. So evening we are going to, first I will ask questions related to what topic I taught in morning, and evening we are going to study the remaining part of it. Okay, I hope you might have enjoyed today's class. Okay, bye everyone. Good. Evening 5 p.m. Why evening 5 p.m. Kanishka?